So that's
So this is a situation where IDA thinks it's figured things out, but it's not always right. So remember, IDA starts out, it starts at the entry point, okay? And it starts going through, it defines code, and then it uses that defined code to find other code. So it sees a call, and then it goes off to that address and starts defining code there. Okay, so it's a big, just continuous loop until it gets to a point where it no longer has blocks, memory addresses to define its code. And it also has, it identifies string operations. So if it sees a string operation and it sees a variable, a constant pushed on to the stack or used in the code, it's going to go to that address and it's going to define a string.
okay.
So IDA does all this auto-analysis for you, but the auto-analysis isn't always right.
And so that's why it's a red mark.
Well, it's a red mark because it thinks the address is bogus.
Yeah.
So if you've come across a call to a far pointer, and then you see an address in red, IDA says, I don't like this address, so I'm going to color it, make it stand out, and let you know that there's something weird here. So what we're discussing here is there's a function call here. See if I can find the right one. Okay. From the main, the first non-library call, so we've got this memset here. Okay. All memset does is sets all the items in some sort of memory buffer to some character, and in this case, it's actually 0. The next thing we have is this call here, 4010B0. And at this location, you'll see we don't actually work, we've gone out of graph view. And that's because we don't have a function here. We have some weird looking thing. No, we've got push A. What that does is it takes all the general registers, EAX, EBX, ECX, ESI, EDI, all those general registers, pushes them on the stack. So this is something where you want to save the state of the stack, and later on you might want to restore it, okay? Then we have this call to this function 401070. And then a push EBP and some strange looking stuff after that, okay? So the call is going to take this address, the address of this push EBP line, it's going to push that onto the stack. And then it's going to jump to this address. And you'll note the first thing that happens is a pop. So we're going to take that return address that we want to go back to, we're putting that in the EBP. And then you can see that EBP is used as a reference point down here. So a little weirdness, that's very unusual behavior. So we want to try to figure out what's going on there.
What should I make of this test EAX thing? My gut says that this is always true, right?
Well, test EAX, so that's an AND, okay? So that says if EAX and EAX, bitwise AND, then that's going to set, well, it's going to set a bunch of flags, okay? But the check after it is JZ, okay? In what case does a test of something with itself result in 0? Remember, it's a bitwise AND.
When they're both the same.
If they're both the same, you might have mixed results. Okay? So bitwise AND says 0 and 1 is
False.
right. 0, 1
Want to be the same bits.
right. 1 and 1 is true. 1 and 1 is the only situation where it's true. Okay? So if you have 1 and 1, then yes, it's going to keep doing your loop. But if you have 0 and 0, then it's going to fall through to this side here. So when EAX is 0, this test is going to fail, or succeed, right? It's going to jump.
So you want to have an address that's, so in order for this loop to continue, EAX is basically the pointer has to be 0. The address has to be 0 here, because that address is being set to EAX. So 0 and 0 is...
EAX is getting something stored at EBP.
Right.
Okay, whatever that pointer is, which we know it's that place you just came from.
Right.
Okay, so we're going to keep looping until we reach 0. When whatever's stored at that location is 0. That's when we'll leave the loop.
Right.
Does that make sense?
How does IDA figure out a lot of these variable lists? Is there debugging information we need?
Okay, so the import names.
No, like file name and path name.
Okay,
Because this is just one of the functions, and it's not imported or anything.
that's a good point. So IDA has information about each of these Windows APIs, and it knows what all the. So if you look at the MSDN document,
Is it using the arguments for the functions that get called to infer what variables must be?
Yes, exactly. So this is something actually that I should have put you guys on earlier. MSDN is a very handy tool, and I'm just going to, I believe it's msdn.microsoft.com, msdn.microsoft.com. If I go to the library, so from the main MSDN site, I have this ability to search all the different API functions, okay? And let's just say I want to know what arguments create file takes. Okay. Found create file function. This is the function prototype for create file. Okay. If you notice, you'll actually recognize some names here. So IDA actually has this information. It knows that if it sees a call to create file, then it will put comments into the disassembly with these names: LD file name, DW desired access. So IDA's doing that work for you. Now, you may want to use MSDN because you found a function that's dynamically loaded, and IDA wasn't able to actually provide you with that information about the arguments. So, by now I hope that some of you have found that the API resolution method that I showed you before, using the hash calculating, getting the headers, and doing the rotate 13 to calculate a hash is used, and eventually you're going to get some sort of dynamically loaded functions out of there. And that's where MSDN is going to come in handy. You're going to figure out what those functions are, and the debugger is going to help you there. And once you figure out what those are, you can use MSDN to figure out what are the arguments to that function. How can they help? One of the tricks to using the debugger is asking yourself, at what point do I get my answer? Okay, so you start out setting breakpoints where your result is going to be, where you know you're going to have the result of the problem you're trying to solve. And then, if for some reason, whether it's anti-debugging tricks or something, you then want to start backing up your breakpoints. Try to find a place earlier in the code assuming that, say, your code isn't breached or you weren't getting the results you were looking for. So who over here can tell me what this function call is here, this sub 401020?
It looks like it's the thing that looks for procedure addresses. It's the thing that hunts, gets the kernel and base address, and then it hunts, does the hashing, searches.
So I call this.
Yet that it,
I'm
I
sorry.
haven't completely convinced myself that it gets out the proc address, but I think that's what it's doing at the end.
Okay, this is our poor man's get proc address. I showed you this earlier. So I'd recommend labeling this.
I want to call it get proc address properly, it'll confuse quite it. It'll start putting in the, start naming things, arguments.
Yeah, you can't call it get proc address, otherwise it will collide with the actual get proc address. So the reason I was looking at that function to begin with was I showed you earlier from the main, I got to this location. It had this call, a strange pop at the beginning of the function, which takes the return address off the stack. And then there was this call here, and I wanted to figure out what is that. And from what we saw earlier, this is this get proc address routine. Josh brought up a good point. You'll see we access argc and argv at the beginning of the main. So argc, argv. Argc is the argument count, and argv is the array of arguments. So we have this compare here. We check to see if we've got two arguments. And if we have greater than two arguments, then we come down to the left here, and we just leave the application.
Greater than or equal, we go.
Sorry, yeah. If we have less than two, right? So jump greater than equal will come to the right side here. So this is saying you have to give at least one argument. Okay, so when this is a dropper, right? So when you executed the thing with an argument, you've got, these are not the bytes we're looking for, okay? So basically what I'm saying is this thing's a dropper, you dropped the wrong file, okay? So somehow we want to get some different output from this dropper, okay? That's what I was going to address afterward.
So with this loop, where it's doing a test EAX, you have to put 0 into the, you have to test 0 and 0 basically to set the 0 flag, right?
That's correct. Okay, I'm going to give you a little tip here. Well, first of all, when I started looking at this thing, I knew this thing wrote a file, okay? So early on, Willie pointed out, I want to know where's create file. That's a really good starting point. So
Where does it get its string?
what's that?
Where does it get its string?
Right. So where does, well, right, that's that's interesting, but I'm more concerned about where write file gets its string, right? Okay, so I'm gonna go ahead and check into my imports. Okay, we've got this create file, but also I've got this write file in here. Okay, so if I double click it and I click on this blue write file here, click X, I can go to the place where write file is called. Okay, and I see a bunch of calls. I'm getting a temporary path, I'm getting a temporary name, and then I'm creating the file, writing it, closing it, and then I'm executing something. So, what gets passed to write file? We've got a file, which is going to come from create file. You see ECX gets H object. That's our H file, and that was the return value of create file A. So just by tracing back ECX, the H file, that's coming from H object comes from EAX, and EAX is the return value of create file. Now buffer is going to be more interesting to me. That's going to be what's actually written, what is the file that gets done out there. So where does that come from? I've got this LP buffer. You'll see here we've got this push up ahead. Push EAX. And that comes from what's supposedly called path name. Problem here is that LP buffer is actually used over and over again here. So this LP buffer isn't actually the LP buffer we're looking for. Okay, that's just a comment. It's because get temp path A actually uses the same argument name as write file. Okay, so where else do I see LP buffer? It's my first argument. You can see it's the first positive argument on the stack here. So the negative numbers are local variables, the positive numbers are arguments. So where's this function called? What's its first argument? I'm going to jump to cross-references here by clicking on the function name, pressing X, and I see it's called from the main. Okay, so LP buffer, I recall that. I want to trace that back further. That comes from EAX. EAX is the return value of this function call right here. So if I go into that function call, I see, start out looking at all the different calls, and there are a bunch of calls to constants or variables of some sort. So that's identified by this D word here. So somehow we've got all these function calls, and in the end I'm going to get a buffer, which is the file that I'm going to write out. So how do I figure out what this is? Well, how is this assigned? By default, it's 0. Okay. If I hover over any D word, any unknown, or any name of a variable, any variable name for that matter, that's not a local variable, I'm going to see what's located at that address. In this case, I see DD0, so it's just a null null 4 bytes there. 4 zeros. So I'm going to hit X to see the cross-references to this thing, and it's used twice. It's used here in this current call that I'm looking at. That's this guy here. And then it's also used with this pop instruction. And a pop instruction is going to put something into an address or into a register. So this is what I want to figure out what it is. Okay, this is going to be where my function pointers are stored. So this is where I want to start my debugging, 'cause now I'll know what functions are called at that location. So I set my breakpoint here. In fact, you know what? I'll set it after those instructions, because otherwise I'm going to have to step through each one of these, and I'll save myself a little bit of time here. So hit F2 on this pop A instruction. I've got my breakpoint. I'm going to hit F9, say yes, and nothing happened. So as we saw before, we actually need an argument. And if you're in VMware here and you've got this bar in the way and you can't see the debugger menu, you can click this pin here and it's going to unpin. You're going to get a tooltip for a moment and then it's going to disappear. You'll see debugger here. In your process options, set a parameter. Try debugging again. And this time it stopped for us. And if I hover over each one of these guys while we're in the debugger, now I see the value that's stored in there. And that's because this information is stored at runtime. So whereas before you would see zeros, now you see these function addresses, like this 7C80BD09. That's the location of this size of resource function, which is contained in kernel32.dll. Lock resource, load resource, find resource. So what I can do is then here I can name this thing. Okay. So you can see this variable name has kernel32, so we got the function name prefixed by the module it's located in, separated by an underscore. So I'm going to stop debugging. And I'm going to hit escape to go back to where this call was. And now I can see the flow of the program and how it's actually using these functions. So I see find resource A is called, and kindly IDA actually gives me the information what the arguments are to this. Then I see load resource, size of resource, and lock resource. And you'll note after lock resource is called, there's nothing is done with EAX. So that is so we're actually going to get the return address of lock resource, and that is our buffer. That is our pointer to our buffer that we're actually going to write to the file. So we really want to know what does lock resource do. And since it's called after these other guys here, you can assume that somehow they probably affect what the results of the lock resource are. So this is where you'll pull out MSDN and figure out what those do. I'll give you a little bit more time. We'll take, let's say 10 more minutes, and then we'll talk about a much easier way of solving this. So there's information missing from IDA, and this is because of the way we decided to load this thing. Okay. And what are we missing?
Resources.
Okay. So we're missing the resource section. So I can actually, I'll just go ahead and demonstrate to you how we can actually load those resources. I've done all this work. I don't really want to overwrite this thing, so I'm going to rename this thing. So I renamed my IDB from dropper to dropper.working. And I'm going to reopen my dropper application here. And I'm going to click on load resources right here. And now compare this to what I had before. See how I've got a big black section right here at the end, and I've got a lot of different stuff in here. So if you look closely, this is the original one, and this is the one with the resources. So up until this red stuff, everything's actually very similar. You've got this pink section, you've got these greenish sections, you've got a little black section here. The difference is that this is squashed down when we have the resources available. So what we're saying here is, okay, we've got the resources at the end here, this red and blue stuff. And that's interesting because that's saying in the resources, there's something that IDA thinks is code, okay? There's actually some blue stuff in there, and that's what IDA's analyzed and decided is code. So that's really interesting. Now, deciding whether or not you want to load the resources is kind of up to you. You'll kind of get a feel as you go along when you want to do it and when you don't. Typically, there are other tools that are better for looking at the resources, because IDA is just going to show you, you'll see, it's just going to show you a string of bytes, or it's going to define code, but you have no concept of
Doesn't parse the resource table.
Right, of the resource table itself. So you could actually have IDA organize things, organize the resource structures, but you know that's an effort that is kind of painstaking. I mean, you could actually write a script in IDA, and IDA provides this IDC. It's a C-like language that allows you to manipulate the database, and I'd be happy to answer questions about how to use that offline. We won't discuss that today, but you could actually write a script that whenever you have a resource section and you load it, IDA goes ahead, runs a script, and parses this whole thing. So that's a possibility. But I showed you CFF Explorer earlier. And that's not in my VM. Actually, still have it running. So if I open up dropper.exe in CFF Explorer, I can actually use this resource editor. And in the resources, I've got byte bytes and great job,
Which is itself executable.
which if you glance at it, you'll see it's got an MZ. It's got this program cannot be run in DOS. Okay, we've got section header names. These are very common. .text, .rdata, .data, .rsrc. So it has its own resources. So now we've got some sort of executable, and we have this other piece of information. We've got this one's named bytes, and it contains our text file that we saw that was displayed with Notepad. Now we've got great job. So, any thoughts as to how to get that out of our executable?
Can we just look at the offset in the file here and then pull it out?
Sure.
Because I mean, the
How are you gonna
header is
pull it
gonna have
out?
a length. How would I pull it out? Probably with the like little C or Python program or something to go to that offset in the file,
Win
read
X.
X bytes, and then write it to a file.
Right. So you can go ahead and script it. Well,
I like his solution too.
one possibility
Right click save as.
is
Can you
we
do that?
figure out how we know this one's accessed, right? Okay. And has anybody looked up the resource functions on MSDN?
Yeah, I looked a couple up.
Okay. So we'll just go through the sequence of calls. Okay. I'm gonna jump to where this is called. We've got find resource first. What does that do? Find resource.
Find where this little binary lives in memory.
What's that?
So find where it lives in the memory.
Well,
Find where it is in your process.
right. So it takes a name. Okay. So going into MSDN. I want to figure out what is that name. So one thing I want to point out is I'm not going to actually search for find resource. What was it? Find resource A. Okay, I'm not going to
This is the
search.
ASCII version.
I'm not going to search. Right, exactly. I'm not going to search for find resource A. When you see that A at the end, or if you see a W at the end, that indicates a specific version of the function. So when you write your code, you're just going to call find resource, okay? But in the background, your compiler says, are you using ASCII or are you using Unicode, okay? So if you're using Unicode, then you're going to see find resource W, and if you're using ASCII, it's going to be find resource A. So I trim off that A, search for find resource, and I see the name of the resource. The name of the resource. So this is the name of the resource right here, bytes. Okay, so I'm finding that. So where did I get the name from? So I'm going to trace back here. In fact, I want to see where a get file buffer is called. Okay. Find resource. So it actually gets binary. So binary is the, what is that third argument? That is the type. So type of resource, and the argument, arg0, is actually going to be our name. So I want to see where this is called. It's called twice, so I'll just choose one of them. And you can see there's a case where okay, it's called once, where I'm getting one of my arguments to this function. So argv contains the arguments, and this is going to get the second argument. So the arguments array is loaded in EDX. Then I go 4 bytes from the beginning of that array. So the argv is actually just a list of pointers. Each one points to a string, each one of the arguments. And so that's telling me I want to get the second argument. So 4 bytes in is going to be the second argument. So if this works, if this whole get file buffer succeeds, it's going to go over to the left here, and it's going to set command line to null, to 0. Otherwise, it's going to come to the right and call the same function with bytes. So what I want to pass to this is, what I want to pass to this application is the name of our resource that we're interested in. So what are we going to pass to command line? Great Jordan. So if you run this, great Jordan, and we have an application. So something has run. It's printed some messages to the screen. It's got a blinking cursor. Get some input. Don't know what happened.
It just doesn't show the command prompt after it terminates, but not very cleanly.
Right.
So you're saying you don't think that DB is the best way to get that file out of the...
DD would work, absolutely. Now you're not always going to. It's not always going to be that straightforward.
Yeah, it could be
But
obfuscated
yes.
in a wide variety of ways.
So one thing I want to point out is that this is written to the temp directory, or you can see that there are things being accessed from the temp directory. All right. You can access this by opening up a file browser, %temp %. It's a really handy shortcut. It's using an environment variable, and this is your actual temp path. And if I look at this, the details view,
Just disappeared.
sorted by date modified, you'll see at the end here I've got 3 different files, re_7.temp. If you analyze this a little further, you would have seen that re_ is actually a prefix that I used when calling the temporary file name function. And if I just take a look at one of these in Notepad, the first one is, these are not the bytes you're looking for. So these are actually going to be, these other items here, those are going to be our dropped executable. But because we ran it twice, we have 2 different files. So Andrew was pointing out that we could use CFF Explorer to help us out here. So it's already gotten us this far. One of the handy things about CFF Explorer is you can actually choose a resource, right-click it, and save it. So you'd save resource raw. I'll call this dropped.exe. I should remember where I saved it. It actually should be available to all of you now. It's in the share. So there you have it. So we'll come back to that soon. We'll take a look at that in the afternoon. But for now, I think we'll take a break for lunch.